today? You. There you go. That's beta. That's actually a Greek B. All right, here we go. Please pay attention. I'm not going over this in class after today. Now, this quiz went exactly how everything's gone lately. 3 or 4 people did great. The rest of you just kind of did your thing, which has not been right for a while. Right, the rate law. So I'm going to look right here, and these are held constant. I look right here, and these are double. And what happens to the rate? It doubles. A 2 equals a 2 if you raise that to the first. Okay, thank you. So our rate equals K, and we know at least H2 is raised to the 1. Then we got to find our P4 and see what it's raised to. So we look for a place where that's held constant, and there is one. Did I write this the wrong way? All right, where H2 is held constant. I'm sorry, that's constant there. Then this is doubled, right? And what happened to the rate? It stayed the same. How is there no change? We multiply by 2 and you get no change. That's one word now. No change. All right, how did that happen? That's because it is raised to the 0 power. All right? If you change the concentration of something and the rate does not change, then the rate is not dependent on that concentration, and we raise it to the 0 power. Now, a bunch of you did not write this because it was to the 0. As far as the rate law, it needs to be written in there. Now, the math, who cares from now on, but the rate law, it needs to be written in there. Are we okay with that? Uh-oh. My undo button is right there. Oh well. So pretend it's there. What is the value and units of K? So I'm going to erase this and obviously rewrite that now. All right. So K will be equal to the rate divided by raised to the first, right? All right, pick the row you want and just do it. So K would be equal to the rate, 3.2 times 10 to the negative 4, divided by the concentration of H2, 0.0075. And what was this answer? A lot of you did have this one right, by the way, so feel good. What's that answer, somebody? What's that? .043, and then we solve now for X. So X is the concentration of H2. So we know K equals that, so it's rate over X, essentially, right? What? Okay. So to solve for X, you take it over and then K under, right? So X will equal your rate divided by K. And we just find those values from up here. Your rate was 7.2 times 10 to the 4th or negative 4th? Negative 4th. And K was 0.043. Is that right? And you divide that and you get some number that I don't remember. You have it right there? 0.017. All right. That's that. Good. So that would be, we would curve that. Yes. That would be a that. I think Visky did it better, though, personally. Mine's respectable. If I meant to do that, that would be cool, but that was an accident. Okay, good points, all of those. All right. All right, so we did this already. Most of you got this right. This times that is 1.5. Divide it by 2, and you got 0.75, which was your answer. So you take the coefficient of the thing you're solving for, that's on top, the coefficient of the thing you're given, and then you multiply that ratio by the rate that you were given. Go. Yes. It says not a lot, but very often. Because sometimes these units, they don't make sense, and they take a long time to work through. And also, they won't put the units sometimes because a kid can use the units to figure the answer out, like in their multiple choice. All right. Next. Here we go. So the next thing we would do is put this in our calculators. If you didn't get this right, then take your calculators out and put it in. The answer for the rate law was rate was equal to K times A raised to the first. They were both first order, I guess, you said yesterday. All right. Then the value of K. All right. I don't know. This didn't go as well as I thought it would. So to find the values of K in your calculator, you would have added a third row, which was the ln of A, right? You okay with that? All right, when we put those in, we get some numbers. I'm not going to worry about them. And then we plot our graph, and we would have discovered a line that looks something like that. Might be in that region. I don't remember what quadrant it was in, but it doesn't really matter. And then the slope of this line is equal to what? Negative K. All right. So we would graph that data, find the line, take the slope of it, and the slope ended up to be what value? Negative 0.02, which meant that K was really 0.02, which honestly most of you had 0.02. That wasn't your problem. Your problem was algebra, which is fine. My problem in my entire life has been algebra and Mountain Dew. So if I could get both of those better, I'd be a lot better. All right, what would the concentration of A be at 150 seconds? So we need to know the first order rate law. So you had this. And we're going to have to algebraize that thing right there, right? So the rate law says the ln of AT equals negative KT plus the ln of A naught. We all right with that? Okay. Before I do algebra, I plug numbers in because I like moving actual numbers instead of other things. So this is a number I can calculate right here. I know the original concentration is 0.25. Is everyone okay with that? So I'm going to solve for this term in my calculator. So what is the ln of 0.25? Oh, negative 1.38. We all agree with that? Are we good so far? All right. Now, what would the concentration be at 150? So I can also plug that value in, correct? So I know K is 0.2. So I have negative 0.02 times the time, which is 150 seconds. Make sure these were seconds. They were. All right, so what is negative 0.02 times 150? 0.3? Or 3? Just 3? Okay. Well, yeah. So that's 3. Now, I already accounted for that negative, right? So that negative is gone. So I have 3 plus minus 1.38, which is just really minus 1.38, correct? You with me? All right. So I now have the ln of AT. This one you really didn't have to move around. The next one you will. Equals, what's that, 1.62? Did I do something wrong? Okay. When those two girls start mumbling, I get a little nervous. All right, so now the ln of x is equal to 1.62. So I have to do the inverse of the ln, which on your calculator, if ln is a button on your calculator, that's the ugliest button ever. But the way to get the inverse of that is to press the second button and then hit ln. When you do that, that will give you e, correct? So we will take e and raise it to 1.62. And that should give us an answer. I don't know what they're doing today, but it is driving me bonkers. So what did you guys get? 5.05? That doesn't seem right. Yep, definitely can't be right. What do we do wrong here?
That's what I was thinking the entire time. Because you're taking negative 1.2 times.
Did I not already? I thought I did already count it in. Well, yeah, I couldn't have, so it does have to be negative. All right, so that's negative 4.38. Sorry. No?
That's right.
Which would mean that. That looks a lot better. .0125. Is that what you guys got? Yeah. Okay. We'll call that good then. All right. How do we feel about that? A lot better now? Okay. We're going to do the same problem. Will you, if you got any of this one wrong, will you redo the whole thing now that you feel better about it? Now, if you only got this one wrong, which I actually didn't even correct. None of you had the same two answers, so I haven't even worked through it myself. So I didn't mark it wrong if you had an answer, because I don't know the answer yet. So try this one again now that you seem to feel better about how to do these. All right, so let's go ahead and work through this. I'm going to do this a little bit different. The class is now gone. I'll work through this whole thing. Now, I figured out a way to run 2 cameras at a time. Maybe. We'll bring this over here. Now, it's ugly because it flips it, and I don't know how to unflip it. But this is what we're going to do. I'm going to go ahead and put that data in and we'll follow all the steps. So I'm going to go to Stat, and then I'm going to go to Edit, and then I'm going to go to List 1 and put that data in. So 0, enter, 5, enter. Okay, then I'm going to go over, and I'll put L2 in. Okay, now I have my data in. I'm going to set L3 equal to the LN. Ooh, I think this one's one of those that's a little bit messed up, but we'll see. So I'm going to set it equal to the LN of list 2, and I'm going to hit enter, and then I'm going to graph that, and I'm going to hit my zoom 9, and then that's curved, so that's wrong. Alright, now the problem is this calculator is old, so we have to make sure in our stat list that we it will only plot L1 versus L2, but I really want to plot L1 versus this value here in list 3. So I'm just going to go over and set this equal to L3, and that will actually just populate the data that I wanted anyway. And then I think if I hit graph, there we go. There's nothing there, so now I'll hit zoom 9. And now we can see that's a linear line. That was redundant, but now we can see that it is linear. So now I need to know the slope of that line, and I can use that using my stat calc this time, and it's the 4th one down. I just hit enter. And now it will tell me my slope of my line, which is A, is negative 0.072. And I can get rid of that now. And I know it's ugly, but it's backwards, but it's there. Okay, so that data gave me 2 pieces of information. Since the ln was linear, I know that the rate is equal to K times the concentration of N2 to the first. If it was second order, then it would have been curved, and we would not have chosen that. All right. Then we found this value of K using our calculator. It was 0.072. All right. Now, what would the concentration of N2 be at? 150 minutes. I intended this to be minutes the whole time, but I wrote seconds. So since this is first order, we know that it follows the first order integrated rate law, which says the ln of A at some time t is equal to negative kt plus the ln of A naught. Let me double check that real fast so I don't have this wrong. Negative kt plus ln of A naught. All right, so I have that ready to go. All right, so kind of got interrupted. Hopefully we're good. We're solving for this value. So our x is equal to negative kt. So I'm going to put the negative. I'm going to put k in, which is 0.072. Now, if you thought this was negative, you got to remember that k is equal to the negative slope. Because the slope of our line was negative, but k is equal to the negative so that it can be a positive value. So I don't know if that was confusing or not, but that's that. All right, the time, I changed it to 150 minutes, so I just put 150 in, plus the ln of A naught. A naught means the concentration of A at time 0, so that's 0.4. All right, let me get that calculator and type some things in. So I have negative. So 0.72, oh crap, hold on. Negative 0.072. I get this to be negative 10.8, and whoops, plus. If I make a mistake on the math, I'm sorry. I'm not good at making these recording, talking, and doing math all at the same time. And then the ln of 0.4 I get to be equal to negative 0.916. Okay, and my x will be equal to, or sorry, the ln of x will be equal to that value. All right, so I have negative 10.8 plus minus really just means minus 0.916. I get that equal to negative 11.716. And I know the ln of x is equal to that. And so to solve for that, I don't divide by the ln. I have to take the inverse of ln. On your calculator, to find the inverse of something, there's no way you'll see that. But just hit the second of what it is, so second ln, and it will show you that that is e raised to the value. So I just put this in, e raised to negative 11.716. Oops, 716. And then I hit enter. And I get some value that is not the same value kids got earlier, so that's not good. I get 8.16 times 10 to the negative 6th. All right, I checked my math, and I'm not 100% sure that I'm right, but I'm pretty sure I didn't make a mistake math-wise. So hopefully the answer is 8.16 times 10 to the negative 6th. If you come up here, you can notice this change right here of 30 minutes moved it over a decimal. So if I keep going, that would be 90, 120, 150. It would probably move it 3 more places, or times 10 to the negative 6. So it's most likely right. Kids earlier got 0.4 something times 10 to the negative 6. So we didn't have time to check it before the bell rings. There's that. Hopefully you're okay with that type of problem and how to work through those.